Hello everyone, welcome to my YouTube channel. Uh, if you are new, please do well to subscribe. If you are a regular, you are welcome. Thank you for subscribing. Today, we're going to look at integration by partial fraction. Integration by partial fraction. Today, we're going to see how we can express a rational function that is not integrable into an integrable form. In other words, if we have a rational function that cannot be directly integrated, we can resolve it into partial fractions so we can integrate them individually. So we're going to see how we can resolve rational fractions into partial fractions, and then how we can integrate the individual partial fractions to get the solution that we are looking for. All right, without wasting much of your time, let's go into the video. All right. So today, like I said before, we're going to look into integration by partial fraction. Okay. Mhm. Let's take, for instance, that we have the integral we have to evaluate. Let's say example one. Evaluate the integral of 4x minus 5 all over x plus 1 bracket x minus 2 dx. Solution. Before we solve this problem, know that if you have y as ln x, then the integral of y dx, that is to integrate this with respect to x, you will have 1 over x. So we need to know this. Okay? We need to know this. So for instance, another thing we need to know, assuming we have ln, Oh, sorry, I swapped it. I needed to. Don't don't mix it up. Sorry, this should be the other way around. It should be the other way around. If we have 1 over x, this will be ln x. Oh, yes. Okay, good. So we leave it here. We leave it like this. So let's go into the function. We pull out this function for x minus 5 over x plus 1 bracket x minus 2 equal to split this function to partial fractions. We assign the a to the numerator, and then we split the denominator, a plus b. So this rule goes for uh, distinct roots. Assuming we have x plus 1 and x minus 2, just like we have x plus 1 and x minus 2, we know that if we equate for this function to be irrational, for this function to be undefined, x is equal to 0, x plus 1 equal to 0, x minus 2 equal to 0. This will give you x equal to minus 1 and x equal to 2. So these are distinct roots. So anytime you encounter this, sometimes you can have a quadratic expression that you will factorize and have two factors. And then when you have these two factors, you look at these two factors. Are they repeated roots? Is it factorizable? These are the things you ask yourself. If it is factorizable, is it distinct roots, or is it equal roots? Okay. If it is equal root, then it should have repeated factor. That we call it repeated factor. So in that case, you will apply another measure to solve it. All right. So without wasting much of your time, let's go ahead and solve this problem. So we have b over x minus 2. Okay. So now on this part of the problem, we can say LCM of this and this, just like that, is this. Okay. Is x plus 1. Sorry. X plus 1 and x minus 2. So the LCM, this divide this, we have this. So this multiply that, we have a bracket x minus 2. If you have any question to ask, please feel free to ask me in the comment section. Okay, and bracket x plus 1, the same way, x plus 1. So we're going to have ax minus 2a plus bx plus b all over x plus 1 x minus 2. So remember, on this side, we have 4x minus 5 and then x plus 1 and x minus 2. So our duty is to find the value of a and b. So we're going to rule out, if we multiply both sides by what we have at the denominator, they will all go off. And we'll be left with a x minus 2. This should be 2a, sorry. Ax minus 2a, okay, plus bx plus b equal to 4x minus 5. Okay, so now we're going to group this way. We can say the coefficient of x, we group it together, we'll have a plus b. So this, and this will come together, while this and this will go together. So a plus b bracket x, then minus minus 2 and b will come together. So we'll have minus 2a plus b. So this is equal to 4x minus 5 minus 5. So what does it mean? It means that this whole part of the function should be equal to this part of the function. Whereas this part should be equal to this. Okay? So we're going to split it in and form two equations. So we have that a plus b is equal to 4 by comparison. So by comparison, a plus b is equal to 4. We call this equation 1. And then minus 2a plus b will be equal to minus 5. Okay? We call this equation 2. Now, we're going to solve equation 1 and equation 2 simultaneously. So for us to solve that, we're going to subtract. We subtract equation 2. Now subtract equation 1 from 2. Okay, so if we subtract equation 1 from 2, this will be a minus this we subtract equation 1 from 2, so minus 2a minus a minus 2a minus a. That is minus 3a. B minus b, 0. Minus 5 minus 4. That is minus 9, equal to minus 9. So therefore, a is equal to 9 over 3, which is 3. Then substitute a into equation 1. We find b. Okay? We find our b. So if we substitute a equal to 3 plus b equal to 4. So therefore, b is equal to 4 minus 3, which is 1. So we fall back to our partial fraction. Fall back to this. Any part you don't understand, please let me know. Okay? Then I'll come in and do it together. All right, so now we have 4x minus 5 over x plus 1 bracket x minus 2. And this is equal to a over x plus 1 plus b over x minus 2. So we found our a to be, 3. This should be 3 over x plus 1, and b to be 1 over x minus 2. So we can now integrate both sides. So we introduce our integral. Integrate both sides of the equation. So we have that the integral of 4x minus 5 over x plus 1 and x minus 2 dx. This should be the integral of 3 dx over x plus 1 plus the integral of 1 dx over x minus 2. So this will be equal to, if we integrate this, remember, I told you that if you integrate 1 over x with respect to x, you will have ln x. Okay, so here there's no, if we differentiate what we have in the brackets, we're going to have 1. If we differentiate what we have here, we're going to have 1. If we had x squared here, it would have been a different integration altogether. But because we have power of 1, we're going to integrate direct, and we will not have any problem. So if we throw the constant out of the integral sign, we're gonna have 3 ln of x plus 1. Okay, ln of x plus 1 plus ln x minus 2 plus what? Plus c, the constant of integration. After integration, don't forget to add c. That gives you that puts it out there that you know what you are doing. All right, thank you for joining me today. We will solve more problems on partial. We will spend quite some time on partial integration by partial fraction, because we will take one of the rules on partial fraction one after the other until we exhaust it. So because integration by partial fraction takes quite a long time, we'll be solving only one example on each video. Thank you very much for joining me. If you are new, like I said before, please do well to subscribe. And if you are a regular, please thank you, and do well to share the link of the video. Introduce your friends to my channel. See you in my next video. Bye-bye.